Today is Tuesday, and we are doing our element of the day. The element of the day is carbon. Here's some facts about carbon that you already know because you already wrote this down. You know that carbon has 6 protons, 6 neutrons because 12 minus 6 is 6, and 6 electrons because this is electrically neutral. It is found in group 14, group period number 2. The period 2 gives me a huge clue. It tells me that this atom has 2 electron shells. Everything in group 2, or period 2, excuse me, has 2 electron shells. Carbon is a nonmetal, but it is a solid substance. It has 4 valence electrons, so the Lewis dot structure would look exactly like this. Add to your element of the day. Here are some facts about carbon. Carbon has an appearance of being a black, solid, non-metal. Carbon can come in a lot of different forms. Carbon makes up charcoal, but under extreme pressure and circumstances, carbon can also make diamonds. Carbon is also used in graphite, which is like what's in your pencil. It's also used to make something called buckyballs, which buckyballs is a molecule that scientists are putting together that actually they can put medicine in, and then this thing, the structure made out of carbon atoms, can actually travel to a certain place in the human body and administer the medication where it needs to go. So this is a really, really fabulous and amazing new technology that medicine has come up with in the last few years. You need to know this. All living matter contains carbon. If it's alive, whether it's a plant or an animal or a human being, if it is alive, it is considered to be carbon-based. Fats, sugars, and fibers are all made out of carbon, and organic chemistry, which is the chemistry of all living things, is all based off of carbon. So carbon is used in a lot, carbon is found in a lot, carbon is the basis for all living things. So I hope you got that for the element of the day. When you're ready, flip on over to IP 49. This is where we're going to be taking our notes for today. Take a moment to pause the video and set up your notes on IP 49, titling it Elements and Compounds. And here's our essential question. Compare and contrast the elements and compounds. Like, what is the definition of an element and a compound? How do their properties compare? And how do their symbols compare? When you are done setting up your notes, you can move on. Today you will be writing questions, and you will be completing your essential question answer at the end of these notes. Here we go. There's going to be 4 sections to your notes today. The first section is the first section on elements. The first thing that you need to make sure that you have down is the definition of an element. It is a pure substance made of only one type of atom. For example, gold or anything else on the periodic table is an element because it is made of pure atoms, all the same atom. Gold is pure gold because it is only made out of gold atoms. Something else you need to know about elements is that an element can't be broken down any more simple than it already is. Like, if you cut gold in half, you would still only have gold atoms. If you took out a section of nickel, you would only have nickel atoms. If you took out a section of silver, you would only have silver atoms. An element cannot be broken down any more simple because it's already in its most simple form. Take a moment and write a question from this section on elements. Section number 2 is also about elements. You need to know, well, you probably already know that there's over 100 elements found, and they can be found on the periodic table of elements. We've talked about this already, but this is extremely important now that we're talking about the symbols of elements versus the symbols of compounds. The symbols of an element have 1 or 2, and there's just a few cases where an element has a symbol where it has 3 letters, but usually an element will have 1 or 2 letters, but only 1 uppercase or capital letter. For example, C for carbon, 1 uppercase. B for boron, 1 uppercase. He for helium, but there's only 1 capital. Same thing for aluminum. Recognize also that this is a lowercase l. This is not an I, because if it was an I, it would look like that. So anytime you see this symbol, that is in capital A lowercase l. You'll see the same thing when you get to chlorine. Chlorine looks like that, capital C, lowercase l. Take a moment to write a question about section 2 of these notes. Section 3 is about compounds. Now here's where things get a little bit more complicated. A compound is also a pure substance, but it's a pure substance made of one type of molecule. It can be two or more different elements that have been chemically combined. Like, here's two examples of compounds. Salt is an example of a compound. Salt is a molecule of sodium and chlorine chemically combined to produce sodium chloride. Pure salt is pure, that's why it's considered still a compound. It's considered still pure because this is all sodium chloride atoms, or molecules, excuse me. Pure water can be considered pure because it is all pure H2O molecules. But it is a molecule, hydrogen, hydrogen, and oxygen put together. Both salt and water are molecules, therefore they are compounds. You also need to know about compounds is as you're comparing the symbols, the symbol for a compound will have two or more uppercase letters. That's how you can tell the difference between an element and a compound just by looking at the symbols. If you'll notice that this symbol for salt is NaCl, here's two capital letters. And the same thing happens with water. If you look at the symbols for water, there are two capital letters. That's how you know that this is a compound, because there are two or more, there could be more capital letters. Once again, for an element, there's only one capital letter, and for a compound, there could be two or more capital letters. Here's another contrast between elements and compounds. Elements only have about 100. There's only about 100 elements found on the periodic table. There's millions of different combinations of how those elements can get put together to create a compound. Here's some other extremely important facts about compounds. Compounds cannot be separated by physical means. Meaning, if I had water, I can't just pull out the hydrogen from the oxygen. Since the molecules combined chemically, they can only be separated chemically. Like if I tried to take out a water molecule, guess what I would still have? A water molecule. I cannot separate out the hydrogen from the oxygen unless I have special chemicals in a lab, and this is called electrolysis. If I have special chemicals in a lab, I might be able to separate the hydrogen from the oxygen, but not unless I have special chemicals in a laboratory. Here's an extremely, I hope you highlight, I hope you box, I hope you exclamation point. You need to know this about compounds. Compound properties are completely different than the individual properties of the elements. For example, hydrogen is a gas that's flammable. Oxygen is a gas that's flammable, but you put them together and you get a water molecule. Yesterday, you saw this when we talked about our iron sulfide demonstration. The elements or the properties of this compound is totally different than the properties of these individual elements. Once it becomes a compound, it is no longer iron and it is no longer sulfur, because iron is a magnetic metal and sulfur is a soft nonmetal. And somehow it becomes this solid rock, black, non-magnetic compound. The properties of the compound are totally different than the properties of the individual elements. Once they chemically combine, it is a whole new substance. So, if you have not already written a question about section 3 and a question about section 4, make sure that you do that. You need to highlight important facts through your notes. Color pictures. You should have pictures in your notes. You should have 4 questions, 1 for each section. And because there were 4 sections, you should have at least 4 sentences to answer the essential question. If we go back to the essential question, after you've listened to these notes and this video, you should be able to compare and contrast the definitions of an element and a compound, compare the properties of a compound to the properties of the elements, and compare their symbols. And I will see you tomorrow after you have done IP 49 and you have also started OP 49. This is your homework tonight, determining if something is an element or a compound just by looking at the symbols. read this as a review, and complete OP 49 by tomorrow. I'll see you then.